Basic trigonometric definitions. Angle is generated by rotating a ray about its fixed endpoint from an initial position to terminal position. So if we have this to be our initial side, this is my terminal side. If I rotate this endpoint from here to here, the angle I get, the measurement I get is the angle. Initial side is the initial position of the angle. Terminal side is terminal position of the angle. The vertex is the fixed endpoint. So here the vertex will be right here. Positive angle then, the angle measured from initial side to terminal side in counterclockwise direction. So counterclockwise or anti-clockwise direction, we get a positive angle. Opposite to that is the negative angle. So if we measure, if this is our initial side, this is our terminal side. If we measure in clockwise direction, the angle measured is the negative angle. Okay. Coterminal angles then are angles that have the same initial and terminal sides. So 30 degree here, positive 30. If I go counterclockwise or anti-clockwise direction, the one complete circle is 360 degrees. So if this much is 30, if I go from here to here, it will be negative 330 degrees. Or I can go 30 degrees and then one more complete circle, which will be adding 360 to the 30, we get 390 degrees. So 30 degrees, negative 330, 390. All of them are coterminal angles to each other. Let's see some examples. Determine one positive and one negative coterminal angle. So we can get too many coterminal angles. The one we want here is one positive, one negative. Does not matter what will be the number. So if I subtract 360 here, we get 110 degrees, and that gave me one positive coterminal angle I wanted. The next one, the negative coterminal angle, we can subtract 360 from 110. So 110 subtract 360, we get negative 250 degrees, and that is the one we got negative. Now this, as I said, these are not the only two answers. I could keep subtracting 360 and get other answers. Or if I can add 360 to here to get 830. So 830 will be my positive angle, and then 110 will not be the other answer because we need one positive, one negative. So I can say 830 and negative 250, or 110 and negative 250. As far as we get answers by adding 360 or subtracting 360, multiple of those, and get one positive, one negative answer. Let's look at another one. For negative 190, we can add 360 to it. We get 170 degrees positive. So that's one of the positive angle we can get. The another answer I could get is, if I subtracted 360 from 170 like the previous example, I'll get negative 190. So I'll be back to the question. So we have to do something else. We can do 190 minus 360 here. So that will give me 550 degrees negative. And that will be my negative coterminal angle. So positive coterminal angle 170, negative coterminal angle is negative 550 degrees. Degree then is basically 1 out of 360th of one complete rotation. So 1 degree is out of 360, it's 1 out of 368th part. Okay, 1 out of 368th part. Okay, so we write 1 degree as this. Now, you know how for distance we have different units, like kilometer is a large unit, meter is a bit smaller unit, then centimeter is more smaller unit, millimeter is even smaller unit. Similarly, for angle measure, degree, then we can measure it in a smaller unit than degree is a minute. It's 1 out of 68th part of 1 degree. And then even smaller unit will be second. A second is 1 out of 60th part of 1 minute. So the minute we write it as 1 minute like this. Second we write with 1 and double dash. So it's like kind of feet and each symbol here. So 1 degree is equivalent to 60 minute is equivalent to 3600 seconds. Example here. Convert the following from decimal degrees to degrees minutes and from degree minutes to decimal degrees. So the first one is in decimal degrees. We want to get rid of decimal and convert into minutes. So the decimal here we have is 0.3. So if we know 1 degree has 60 minutes. So if you multiply 0.3 times 60, we get 18 minutes. So then answer here will be 35 degrees and 18 minutes. For the second one here then, we are given degree minutes and we want to convert into decimal degree. So what we can do here is we can say 25 divide by 60, which will give us roughly 0.4166666. So then the answer we will have here is 67 degrees, or not exactly 67 degrees and 41.666 degree. So basically it will be 67 plus 40.41666. So we can say we will have 67.417, roughly that many degrees. Okay. Standard position of an angle is the initial side of the angle is the positive x-axis and the vertex is the origin. So for example here, this one, the angle in standard position will be from positive x-axis until there. For the second one here then, it will be from positive x-axis going from here to here to here. For this one then, it will be just this small angle here between x-axis and this line. And for this one again, we'll go from positive x-axis counterclockwise direction. So we'll go from here to here to here to here. So that will be the standard position of an angle. We are asked to draw angles in standard position such that terminal side passes through the given points. So we have -2 and 7 as the first point. -2 and 7. So this is what we will do. We will say here, let's sketch this quickly. We will say -2, x is -2, y is 7. So we will have, so x being -2, so that's somewhere here, and y being 7, so y 7 positive here. So this is the point where we have -2 and 7, and the point the terminal side we draw is here, and the angle in standard position from positive x-axis counterclockwise direction there. So this one we'll call theta, angle in standard position. For the second one then, we have x to be 4, y to be -2, so x4, which will be somewhere here, y -2 down, so this point here, x4, y -2, so we sketch something like this as our terminal side, and the angle always starts from positive axis. For the standard position, go counterclockwise or anti-clockwise, and we keep going, and this angle right here will be our theta. Okay, so for the next one now, we have x to be -3, y to be -1, so x is -3 somewhere here, y -1 down, so this point right here, let's say, is -3, -1, so we sketch somewhere here, -3, -1, and the angle from standard position, positive x-axis in counterclockwise direction, we'll call this theta. And for the last one, we have x0, y5, x0, y5, so it's somewhere here. So angle in standard position will be 90 degrees from here to here. First quadrant angle then, it is in standard position, the terminal side is in the first quadrant, similar to the terms used for terminal sides fall in any other quadrant. So this example here is angle in the second quadrant, third quadrant angle, and this is the fourth quadrant angle. In standard position, the terminal side collides with one of the quadrants. Okay, so this one is basically, it's in the first quadrant because it is between first and second quadrant. Radius vector, the distance are from origin to the point, we call it radius vector. So this is our radius vector, this is our radius vector, and so on. Acute angle, angle between 0 degrees to 90 degrees is the acute angle. Right angle is the angle between exactly 90 degrees. Obtuse angle then is angle measuring between 90 degrees to 180 degrees. So acute between 0 to 90, Right angle exactly 90, obtuse angle between 90 to 180 degrees. Complementary angles are then the angles for which their sum measures to the sum of their degree measures to 90 degrees. So two angles adding up to 90 degrees are complementary angles to each other. Supplementary angles are the ones for their sum equals 180 degrees. So if two angles adds up to 180 degrees, those two angles are supplementary angles of each other. So here, for example, A is the acute angle, B is the right angle, C is the obtuse angle because it's more than 90 but less than 180 degrees. Angle D here, two angles here, this angle and this angle, because it adds up to 90 degrees, those are complementary angles to each other. And for E then, the angle here and here, this angle and this angle adds up to 180 degrees. So this and this are supplementary angles to